All right, so I wanted to quickly demonstrate how I solved the issue from the last video. I got a comment on that video from somebody talking about octrees, and so I wanted to quickly kind of go go through that because it's funny that we came to the same solution, more or less, although I think mine is a little bit different. And so I'm going to try to explain sort of the solution I came up with for this issue where, we need to define chunks in 3D space here in a way that they all align so that when you have different sizes, different size 3D cubes essentially in a 3D space that outwardly grow in size, they need to always be a specific size, or else the grid, this 3D grid, is not going to align properly. And so, the obvious solution seems to be an octree, but I did it a little bit differently than a typical octree. And so, what you see here is a diagram of an octree where you're starting, and I found a few diagrams actually. Maybe I can. Oh yeah, this one's pretty good. So when you're starting with the largest cube, what an octree does is just divides it into 8 smaller cubes, and then divides each of those into, or one of those really, into 8 more smaller cubes, which is actually, this is really close to what I'm already doing in individual chunk generation in order to optimize it so that the scalar field points, each scalar in the scalar field, doesn't need to be checked in order to decide whether or not to even generate that chunk. So if you have a chunk that's in empty space, it basically goes through this exact type of structure where it starts with the largest cube and then checks all of the corners of the cube, and if all 4 or all 8 of the corners are empty space, then it just skips the chunk entirely. But if they don't all match, then it goes down into smaller. It goes into one smaller cube, so it doesn't go into 8 like you see in this diagram. It's more like this, really. It's like this node structure where you have all 8 corners, and then for whichever corner is the largest difference, it goes into that specific direction and then gets a smaller cube, which in this case, the cube you can say is half the size because, well, each edge is half the size, but it's really 1/8 of the volume, right? Because it's as you can see, it's only one of 8 smaller cubes, and that's actually key to understanding what I'm doing for the actual overall 3D structure of the chunks. And so I've got a few different. I found all of these online, all these different diagrams, but really I couldn't find one that properly illustrates how I'm doing this in reverse. This one's not too bad, but actually this one, it's almost what I wanted, but not quite, because, so I'll start with this. So this part here that you can see, these really small squares, this is in the exact structure that we want for our initial layer. I'm calling them layers, so each time the size increases, that's a new layer in the grid. And so what mine looks like is very similar to this at first, right? You have the smallest layer, and then a larger outward layer, and then another larger outward layer. But in this case, this is a problem because you can see the first layer has 4 squares on each side. So it's what I'm calling an extent. So each layer has its own extent. And for the first layer, it needs to be, for each layer actually, it needs to be divisible by 4. This is just, I'm not going to be able to properly explain the math behind this, honestly, because I did it a few days ago, and I've already forgotten the more specific details on how the math works. But essentially, each layer needs an extent of 4, or you can think of it even as an extent of 2 starting from the center. So 1, 2 outwards. In the positive direction, it would be like this, 1, 2 outwards. But then in this example here, we run into a problem because this second layer is an extent of only 1. And if you have layers with an extent of 1, then everything gets misaligned. And you can see that here because our center point is right here. I wish I could change the cursor. I don't like this magnifying glass cursor, but yeah. So if you think of the center point as right here in the center of the first layer, and then just draw a line outwards, you can see we're cutting this square in half, and then we're cutting this larger one into thirds, and that's going to create, if you actually encircle the entire thing, it's going to create misalignment, and you'll have overlapping squares or overlapping cubes if you have this structure, right? And so I'm going to try to visually create my own diagram to show sort of how my inverted octree sort of gets around this problem. Okay, so I need to make a correction. I've said something that was incorrect just now. So these diagrams that I was looking at are actually perfectly, they are perfectly what I want, perfectly what we want for this inverted octree. They are aligned perfectly. The reason that I thought that it wasn't is because the way I'm thinking about the extent of each layer is incorrect, and I just explained it incorrectly. So let me try to make a correction here. So if you measure starting, let's say this is our origin point, this is our center, and to simplify it, I'm not showing any other quadrants of the grid. We're just working in the positive direction here. So just imagine this is mirrored, and you'll have the full grid. If you measure diagonally, like I was doing, you end up with an extent of 2 for this first layer, and then an extent of 1 for the second layer, and again an extent of 1 for the third layer. But that is actually incorrect, and as you can see, this still represents an octree, because you're starting with this. You can see it as you're starting with this larger square, and then it's subdivided into 4 smaller squares, and then this one is subdivided again into 4 smaller squares. So it is actually correct. This is aligned. So what's the problem is the way that I'm measuring the extent of each layer. It's not, you can't think of it as diagonal like the way that I was thinking. You have to think of it as the edges. So for the first layer, it's still the same. It's still, of course, an extent of 2. But then the second layer is also an extent of 2, and the third is also an extent of 2. And so if you even have, well, let me show if you where I went wrong here, which, by the way, this is a mistake that I believe that I have currently in my code. So I think I need to fix that, and it's probably going to fix an issue that I've been noticing. So I'll try to show that off as well here. So now you can see we have the second layer has an extent of 3 now. So the way I was measuring before, I would think of this as an extent of 2 because it's diagonally, it has 2. But this would be misaligned, because if now I start adding the third layer, there's 1. And then as soon as I add another one, you can see, oh, it has a misalignment. And then I add 1 here, and yeah, we got a problem. So yeah, so it's as simple as that, really. It just needs to be the extent needs to be thought of as the edges. And since we're working with squares or cubes in 3D space, you only need to measure 1 edge, and it should always match every side, and it needs to be even. And it's completely logical if you think about it. Then an octree needs to have even edges, because if you're subdividing, if you're starting with a square and subdividing it, then every subdivision is always going to be half of the previous size. So it needs to always have a halfway point, which you can only get if the edges are even. So hopefully that makes sense. Now that I'm thinking about it this way, this is so much more straightforward. And now I'm going to take a look at the code and see if I can fix that issue. Okay, back here in the project now. I've made some changes since the last time I recorded this, but it's still it's mostly the same. The only thing you'll kind of notice is currently the level of detail is quite low due to performance reasons. I need to tweak a few values before I bring the level of detail back up. I'm looking into sort of balancing some things there. But anyways, the other issues, you can see there's still seams. That's just going to be an issue for a while, because that's a tricky one, tricky one to solve, and it's just cosmetic. So it's something I'm planning on solving later. And then as I move, you'll see chunks flicker as they kind of despawn and regenerate. It's not flickering too much. It's kind of nice, but yeah. So the main thing I want to point out here is this gap. And so now that we have a much better understanding of how this grid should align, the reason for this gap now should become obvious. And I think it is the exact issue that I just demonstrated. So I'm going to look into the code here and sort of review how I'm defining the extents of each layer of this grid, or of this inverted octree. And hopefully, as I make some changes, I can fix this issue, and then we won't have this gap anymore. And I suspect as well, this issue is also mirrored on the other side. You just can't see it because as the chunks overlap, they when they occupy the same space, they also take on the same shape, because the shape is determined by the location as well. So when you have two chunks that are in the same area, it's gonna just look like one chunk, but it still causes a decrease in performance because they're overlapping, and this unnecessary overlapping going on. So this is obviously very very important to fix this issue. So let's take a look at the code and see if we can figure it out. All right, so taking a look at the code here, I can make it a little bigger. So I have this inverted octree struct, which also has octree layers, which work. They're defined more or less how I was describing them in the visual demonstration, but this really is just a structure of the values. It's not really defining. I mean, it has some functions in here, but for the most part, it's not really defining how the structure is generated, or where individual cells within this structure would be located. It's really only defining these. These three values are kind of the only thing that's being used. And then in my chunk generation code, I'm just using these three values as inputs into some functions that do the math in order to figure out where the chunks go. And I'm finding that this approach, this sort of functional math approach, has been it's been causing problems as I try to update the code and make changes and fix issues. It's been making things a little bit too rigid. So I think in order to, before I fix this issue with the misalignment, I need to really just start moving more stuff into this, into a more structural approach. So defining the entire inverted octree in here without any concern about chunks or anything. It's just going to define the structure, and that's it. And then once you get to the chunk generation phase, it simply takes the values from this structure and then and then it'll use those. And yeah, it should be as simple as that. So I'm going to improve this first, and then after I've improved this, it will be a lot easier to make the change that that fixes the misalignment.